Okay, we are back to talk about MVPs, prototypes, and pilot programs. So let's take a look. This is a visualization of what an MVP should not be and what it can be. So the top row, don't do this, where you start with the wheels, build the body of the car, add the glass or the roof, the doors, the doorknobs, headlights, and motor, and you have a vehicle. Instead, think about developing an MVP through a series of tests and really thinking about minimum viable. So things like, rather than develop the body of a car or the wheels of a car, just take a piece of wood or plastic, any kind of platform, small, one person can stand on it, put on a few wheels, and you've got like a skateboard for transportation. Then take that skateboard, improve the wheels, add maybe a rod and handles or a handlebar. So now you've got like a razor scooter type of thing. It's still manual. Then maybe add a seat and you've got potentially something that resembles a bicycle. Maybe you can add in some gears, brakes, handlebars, and it becomes a more comfortable bike. Then you add a motor, maybe some storage, electrify it, you get a scooter, electric scooter. Then you enlarge the scooter model into a vehicle model, and you end up with something similar to in the first example, but we will have spent less resources, time, and money. We iterate faster, we get feedback along the way. Otherwise, you can build a phenomenal product that nobody really needs or wants or is willing to pay for. Think about the Segway, a phenomenal engineering marvel of a product or an innovation, but not many people are buying it for local transportation or to go to work or school or even leisure. The only use cases that I've seen are mall cops and in some cities, kind of a tourist experience going around a city in a small radius for a lot of money. And so we really want to do it very cost and time effectively and with efficiency. Good Venn diagram to think about this for minimum viable is that minimum means that it just does not suck. Maybe it's a little crappy, nobody wants to use, you can improve that a little bit so it's good enough to build. And viable means that it's got the potential to satisfy that unmet need. And once you have this minimum and viable, it's a product good enough for a startup to start building and iterating its design process. Another schematic to think about is learn, build, measure. So learn fast by building faster using tests and experiments, and then measure to get feedback, continuous testing and learning, and then use that insight to validate or invalidate your hypotheses for the business model or the product roadmap, and then we can move faster essentially. Let's talk briefly about prototyping and fidelity of prototypes. So a prototype is basically a simulation or an expression of a design of an idea for a product or solution. There are static assets versus prototypes. Static assets could include things like wireframes, mock-ups, even a pencil sketch. It could be a storyboard, a visualization. It doesn't really react to a customer's utilization, and there's no reveal per se. A prototype is a design in action with interactivity. So it's got some elements of user interface and user experience, and we can learn from a prototype. We can also learn from static assets like wireframes and mockups and use that to validate a lot of our hypotheses, but we want both. And when we think about prototypes, At the bottom, look at the left side, which are low fidelity, lo-fi prototypes. Quick and easy to translate into some sort of design concept into a tangible, testable asset. Goal is to check and test functionality, not worry too much about the visual appearance or all the nitty-gritty details that ultimately we will be obsessed about. On the right side, we have high fidelity or hi-fi prototypes. It's more detailed, more costly approach to prototyping. And in the middle, got some elements to think about. So what we want is initially lo-fi prototypes, so less realism, less detail, less cost across both visual design, content, and interactivity. And then over time, get to more realism, more detail, and most likely higher costs. There's also a link to learn more about prototypes and fidelity through companies like Adobe. A few things to keep in mind, some concerns. First is customer sets. Do we understand early adopters, power users, enthusiastic people? Be careful about false positives. That means they confirm our hypothesis when in reality our hypothesis was invalid, or maybe a false negative. People disconfirm our hypothesis when in reality they could be valid. So we want enough of a market size to test. Also be aware of unexpected test results. So for example, eBay users contacted PayPal to find out if they can use the PayPal logo on their eBay auction listing. That led to a pivot by PayPal because they got a result that they weren't expecting for a use case, a need. We can also get information from other sources, not from our testing. So for example, bank executives told PayPal founders that fraud was going to eat them for lunch. That information from a source they were not testing, these executives, led to them focusing on fraud rates, measuring fraud and defeating fraud proactively rather than reactively, which helped them quite a bit. Be careful of optimism bias. You might just be a very optimistic person, or some fallacies, like a planning fallacy. Be careful about confirmation bias, which is where we have a bias, have an answer in mind, and then our testing is just finding sources of information that's going to confirm what our bias is already. So we do want difference of opinions and a healthy debate, not 100% of people just agreeing with everything we think and say or do. Sunk cost fallacy is another flawed logic because most people are averse to losses. So if we've spent enough money on it or time or energy, we may not pivot, we may not quit and try something else because we have too much invested. So we feel the sunk cost actually keeps us in a non-progressive state and sink to the bottom of the ocean. Now, once we find out some insights and we're careful about the considerations, we need to think about how do we adapt to the insights we learn, especially if our hypotheses are invalidated. These are called pivots. There's a few types. We can pivot on the feature set, so that's called the customer value proposition pivot. We might pivot on the customer set itself, the customer segment. Maybe it's not the right type of customer. Maybe the right customer is older or younger or more affluent or less, more educated or less. We might pivot on the technology or operations management or strategy. We might pivot on our go-to-market plan, or maybe pivot on our financial model or cash flow formula. So these are all different ways of pivoting. Next, we will talk about metrics.